All right. Hello, everyone. Welcome to Maths with Terry. I'm going to just quickly, we're going to talk about further differentiation in this series. Okay. It's a series on further differentiation, but for the first 10 minutes, I'm going to talk about the standard derivatives, do some review because it's very important for what we're about to explain. So the first one I'm going to start with, so I'm going to do the standard derivatives, a review. Okay, so doing the standard derivatives review. Right. So remember, this series is on further differentiation. So we're doing a review so that to make it more easy for us. Is that okay? So let's start. The first one is when you have y is equal to x raised to the power n. This is a general equation, and you're meant to differentiate this. So remember, I have a video series on all these derivatives. So please, I'm going to put it in the comment section. So feel free to go back, click on it, and watch it if you can. So we have then dy over dx is going to be, bring n down here, and be x n minus 1. So when you're done with this, so for example, we have, let's say y is equal to x raised to the power 5, okay? So we have dy over dx is going to be, you bring down the 5, should now be x 5 minus 1. So the derivative, dy over dx, is going to be 5x raised to the power 4. And that is that, as simple as that. Now, the second one is second derivative for an exponential function. So if you have y equals to e raised to the power x, for instance, so if you just e raised to the power x, when you differentiate that, it's going to give you the same exponential function. So basically, if we have, e.g., we have y is equal to e raised to the power x, so the y over dx is going to give you the same thing, e raised to the power x. Now, but the third one I want to talk about is y is equal to e raised to the power kx. Oh, I didn't write it well. E raised to the power kx, okay? So when you have e raised to the power kx, so that means what you do, and you are told to differentiate this, dy dx. So what you do, you differentiate the power first, okay? It's similar to 2, but I don't want to confuse you, okay? So it's similar to 2 when you differentiate this first, but don't worry. But in y e equals to kx, when you differentiate kx, it's going to give you k. Then you're going to put back e kx. Can you see? So that means, for example, if I have, we have this function, e.g., we have y is equal to, let's say, exponential 3x. Now, the y dx is going to give you, for exponential 3x, you differentiate 3x, it's going to give us 3 multiplied by, bring down the equation back, and this is going to give you 3e 3x. Okay, so a quick review. So the first one, when you differentiate, okay, you bring down the value of this one down, the n down, you subtract 1. When you differentiate e raised to the power x, it's going to give you e raised to the power x. When you have e raised to the power kx, okay, you have e raised to the power kx. So what happens with e raised to the power kx is that you differentiate the kx, and when you differentiate the kx, you bring down the original equation back. Okay. So the next one is, we'll go to number 4. So number 4, I'm going to add a new board now. So number 4, good. So we have for number 4, let's see, right. So for number 4, we have that, good, showing now. Then number 4 is when we have y is equal to a raised to the power x, okay? So an index of anything. So it could be 3 raised to the power x and stuff like that. When is the y over dx, okay? It's gonna be, you take the function away, so it's a raised to the power x, ln of a, that's it. So for instance, if you have y is equal to, let's say, 2 raised to the power x, for instance, So I'm going to have the y over dx will be equal to, see it, ax. So that means it's going to be 2 raised to power x ln. A is going to be what? 2. And that's the answer for that. So number 5, the next one, we have ln x is equal to 1 over x. We talked about this earlier. Okay, so this is the rule. So if, for instance, or let me put it this way, if, for instance, you have y is equal to ln x, let's put it a better way there. So follow the same format like the previous ones. So then the y over dx is going to be, it will be what? If you differentiate ln, it's going to give you 1 over x. So for instance, if I say y is equal to ln x, and I'm differentiating it, it will be equal to what? 1 over x. Then number 6 is, which I'm going to stop with. That will be the final one for this first 10 minutes. It will be y is equal to log ax, okay? So y equals to log ax. So what is it? When you differentiate logs, okay, it's going to give you 1 divided by x ln a. So that means 1 over x ln a. So there's a proving for this, but I'm not going to go into the proving and how you arrive at this. I'm just going to talk about the standard derivative so that we can go straight to the next part of the series, which is the further differentiation, how to use all these in the to differentiate. So that means you have 1 over x ln a. And when you do this, so for instance, if you have an example, y is equal to, let's say, log 10x. Okay, so we now say the y over dx is equal to, it will give you 1 divided by x ln 10. Okay, and that will bring us to the end of this first section of Learning with Terry in 10 minutes. I'm going to quickly go over the review with you. So just to show you, so what I said first is, when you have a function like y equals to x raised to power n, and you differentiate it, you bring the x down, and that will give you x nx n minus 1. So you have y equals to 5 raised to power x, it will be 5x 5 minus 1. If you have an exponential of a function, it's going to still give you the same function, okay? So technically, these 2 and 3 are the same thing. So because when you differentiate x, it's going to give you 1, and 1 multiplied by ex will give you ex, okay? So it's similar to 3. So when you differentiate kx, it's going to give you k, and you now multiply k by ex, and that will give you that. And the second one we talked about was when we have index. So for instance, we have y is equal to a raised to power x, and you differentiate this, it will be a raised to power x ln a. So if you have y equals to 2 raised to power x, it's going to be 2 raised to power x ln 2. If it's 3 raised to power x, it will be 3 raised to power x ln 3. And we have y is equal to ln x, same thing with 1 over x, and y is equal to log ax, it will be 1 over x ln a. All right, thank you very much. Feel free to ask me any question in the comment section, and I will get back to you. All right, so have a nice day, and I'll see you in the next video. So the next video, we're going to be talking about the standard derivatives for trigonometries and similar identities. All right, thank you.